This is the solution for problem 9.28, which we began discussing in last class period, but I'm going to complete the full solution for this video. So it says, a telephone company claims that the mean duration of all long-distance phone calls made by its residential customers is 10 minutes. A random sample of 100 calls, so that means n is 100, made by residential customers taken from the records of the phone company shows that the mean duration of calls for this sample is 9.2 minutes. So X bar was 9.2 minutes. The population standard deviation is known to be 3.8 minutes. So sigma is 3.8 minutes. So part A wants us to find the p-value for the test. So the p-value for the test that long distance calls made by residential customers of this company is different from 10 minutes. So if we're trying to determine if the mean is different from 10 minutes, we have not equals to 10 is the alternative hypothesis, sorry about that, and the null is equals to 10. So now we're trying to find the p-value. So first step is find z-test. We're using z because the population standard deviation is known. So X bar came from the sample is 9.2. Mu comes from the hypothesis is 10. Sigma is 3.8 minutes over square root of 100. And we get our z-test equal to negative 2.11. So this was part of what we worked on in class. Now what we need to do to find p-value is we put negative 2.211 here. This is a z-distribution. And remember, this signifies the null hypothesis. So what we had done before is we've looked farther away from the null hypothesis. So we would be thinking about the tail. However, this one has a little consideration that we hadn't talked about yet. And that is that when this is a not equals to, then p-value is going to be the total of two tails. So even though this is z-test, we're going to find the total of two tails of equal size because the alternative had not equals to. So each of them are the same size, of course, because it's symmetric. So the size of one area is 0.0174. So this one is also 0.0174. So the p-value is a total of the two, or 0.0348. So in sum, it would be only one tail if it's a one-tailed test for p-value, but because it's a two-tailed test, the p-value is also two tails. So the next part wants us to use that p-value and decide if we would reject the null hypothesis if alpha is 5%. So let's make alpha is 5%. This is our level, it first asks for 2%. So if alpha is 2%, it's asking us, would we reject the null? So we're only going to reject the null hypothesis if the p-value is smaller than alpha. So p-value is greater than alpha means do not reject. So we had p-value of 0.0348. Alpha is 0.02, which means we do not reject the null hypothesis. A way of thinking about do not reject means we did not have strong enough evidence to convince us that the mean was not equal to 10 because what happened with our sample was basically too close to the null hypothesis. However, if alpha had been 5%, would we reject the null? Well, p-value would be 0.0348 still, because that's always determined by the sample. But now it would be smaller than 5%, and we would say we do reject the null hypothesis, which means if we're willing to have 5% chance of error that we mistakenly rejected the null, then with 5% error, we go ahead and say we have strong enough evidence to prove to us that the mean is not equal to 10. However, if we had the more stringent criteria of 2% that we just did above, our sample result doesn't meet that more stringent criteria. So we do reject the null hypothesis. That means we accept the alternative hypothesis, which would convince us that the mean is not equal to 10. And this would mean we cannot show mean is not equal to 10.